Good morning, student. Here we are going to start new chapter number 8, Introduction to Trigonometry. Now, you are it is new for you that what is a trigonometry, that we are going to use the angle of triangle, and help of that we are going to measure some sides and some distance in this chapter. Now let how can we just can say, or we can take the measure of sides easily without any actual measures, so that we are going to discuss also in this lecture trigonometric ratios. So let first introduction, how can we say that we can measure the sides, or we can say that the side length of sides and distance between any 2 points uh, is can be said without actual measured. So here you can see that it is here given Qutub Minar, such type of figure. So you know that if you are standing here, as given in the figure, if you are standing here, so can you say that without measuring, without actual measuring, can you say that what is the height of this Qutub Minar, and the distance between Qutub Minar and you without any actual measuring? So, suppose the student of a school are visiting Qutub Minar. Now, if a student is looking at the top of the Minar, at right triangle can be imagined to be made. You can see that Qutub Minar standing perpendicular to the land. So, we can say that here you can find one right triangle, this type of right triangle. So, if he is saying at the top of the Qutub Minar, so this type of triangle may be assumed that it is a right triangle. Showing the figure, can the student find out the height of Minar without actual measuring? If he wanted to measure Qutub Minar, so he have to take a measure from its bottom to its top. But without actual measuring, without climbing up on a Qutub Minar, can he say that what is the height of Qutub Minar? Is this possible? Yes, this is possible with help of trigonometry. Now, some more problems. Yes, as you can see here, suppose a girl is sitting on the balcony of her house located on the bank of a river. She is looking down at the flower pot placed on stage of temple, situated nearby on the other bank of the river. Here you can see that one girl is standing in the on the balcony of her house, and she is looking at the flower pot placed at the stairs of temple on other side of river bank. So a right triangle is imagined to be made. So here you can see that this is a right triangle because it is a 90 degree angle of 90 to be made in the situation as shown in the figure. If you know the height at which the person is sitting, if you know that the height, that is height from bottom to her balcony, can you find the width of river? Can you find the width of a river? Is this possible? Yes, this is possible by trigonometry. And if you wanted to know the width of a river, so you have to swim in river and you have to find, but without doing that you can find the width of river. It is possible by trigonometry. One more example, here given one balloon. Now balloon is in the sky, and after some time it is displaced at here, replaced here at a B, So can you find that the distance that he covered, and also can you say that the speed of balloon, can you find that? Yes, this is also possible with trigonometry. How, that we are going to discuss here. Suppose a hot air balloon is flying in the air. A girl happens to stop the balloon in the sky and runs to her mother to tell her about it. Her mother runs out of the house to look at the balloon. Now, when the girl had spotted the balloon, initially it was at point A, but when her mother came out, then its position was B. When both the mother and daughter came out to see it, it had already traveled to another point B. Can you find the altitude of B from the ground? Means the height at what the balloon is flying, or also you can find the speed of balloon. It is also possible with help of trigonometry. How, that we are going to discuss here. But so that in all the situation given above, the distance or height can be found by using some mathematical techniques which come under a branch of mathematics called trigonometry. The word trigonometry is derived from the Greek word. It is derived from the Greek word tri, it means three. Gon, it means sides. Tri means three and gon means sides, and metron meaning measuring. Metron meaning measure. In fact, trigonometry is the study of relationship between the sides and angles of triangle. Between sides and angles of a triangle. The earliest known work on trigonometry was recorded in Egypt and Babylon. Earlier, astronomers used it to find out the distance of stars and planets from the earth. Now you can remember, now you realize that how astronomers can find the distance between earth and sun or other satellites in the space. So by using trigonometry they can easily find the distance between these all the things. Even today, most of the technological advance method used in engineering and physical science are based on trigonometrical concepts. In this chapter, we will study some ratio or the sides of a right triangle with respect to its acute angle. Respect to its acute angle called trigonometric ratio of the angle, and we call it trigonometric ratio of the angle. We will restrict our discussion to acute angle only. However, this ratio can be extended to other angles also. We will also define the trigonometric ratio for angle of measuring 0 degree and 0 degree and 90 degree. We will calculate trigonometry ratio for some specific angle and establish some identities involving this ratio called trigonometric identities. So let just we discuss what are the trigonometric ratio of an acute angle. For that, first, for the trigonometric ratio you have to just remember two such type of here triangle, acute sorry right triangle. You can see here given angle triangle ABC. In ABC, B is right angle. So if we take angle A, here given two acute angle A and angle C. We can also take C, but let me take angle A. So for angle A, we are going to take trigonometric ratio related to given angle and relation between angle and sides. If so, we are going to take trigonometric ratio uh, according to angle. So according to angle A, AB, according to angle A, AB is a side adjacent to angle A. We say that side adjacent to angle A. And as well as BC, it is side opposite to angle A, according to angle A. And it is the hypotenuse, as we know that. Now if we take the angle C, so sides going to change. If we take angle C and C is a acute angle, so here BC will be the side adjacent to angle C. It will change because we are going to take these all sides according to angle C. So angle C, then it is sides adjacent to angle C, and it will be opposite, AB will be opposite side to angle C, and it is hypotenuse as well as. So it is depending on which the angle that we are going to take. If we take angle A, then AB will be adjacent side, and if you are going to take angle C, then BC will be adjacent side to angle C. It is depending on the angle that we are going to take. Now let us discuss trigonometric ratios. The trigonometric ratios of angle A in right triangle ABC are defined as follow. For that, we have to draw. So we are going to find, or we are going to write the trigonometric ratios according to angle A. According to angle A. So here AB will be side adjacent to angle A, and BC will be side opposite to angle A, and AC hypotenuse. So let some trigonometric ratio that we are going to discuss here. First is sine of A, angle A. This is first ratio, relation between two side, ratio of two sides, that is sine of A, angle A. We can say that sine of angle A is equal to, what is that, side opposite to angle A upon hypotenuse. Side opposite to angle A upon hypotenuse. Once again repeat that, sine of A is equal to side opposite to angle A. Sine A, it is sine opposite to angle A and upon hypotenuse, which is equal to BC over AC. BC over AC. Next, cosine of angle A. Cosine of angle A. Side adjacent to angle A. Cosine of angle A, that is side adjacent to angle A and upon hypotenuse. Side adjacent to angle A upon hypotenuse, that is AB upon AC. Next, tangent of angle A. Tangent of angle A, that is side opposite to angle A upon side adjacent to angle A. Side opposite to angle A upon side adjacent to angle A, that is BC over AB. Second of angle A. Second of angle A, we also say that it is a inverse of cosine of angle A. It is also inverse of cosine of angle A, that is hypotenuse upon side adjacent to angle A, that is AC upon AB. So here second and cosine are inverse, reciprocal of each other. Cotangent of angle A, it is a reciprocal or inverse of tangent A, 1 over tangent angle of A, side adjacent to angle A upon side opposite to angle A, which is equal to AB upon BC. So let the ratio defined above are abbreviated as a sine A, हम उसे कैसे लिख सकते हैं, तो कि साइन ए, साइन ऑफ sine of a angle A, that we can say that sine A, cosec of a cosine of a, that is cos A, tangent of a, that we write tan A, cosec of a, that we write cosec A, sec of a, then we can write sec A, and cotangent of a, that we can write cot A respectively. Note that the ratio cosec A, sec A and cot A are respectively the reciprocal of ratio sin A, cos A and tan A. Observe that tan A, that is tangent of A, is equal to BC over AB. We divide BC and AB by AC. BC divided by AC and AB divided by AC. Then BC over AC, it is a sin A, and AB over AC is a cos A. And in a cot A, it is inverse of tan reciprocal cos A over sin A. So we also can say that tan A is equal to sin A over cos A, and cot A is equal to cos A over sin A. So the trigonometric ratio of an acute angle in the right triangle express the relationship between the angle and the length of the side. So trigonometric ratio shows the relationship between the angle and the length of the side. So using this we can easily find the such problem that we discussed in starting. So this trigonometry is invented or represented by the Aryabhat, one great mathematician, Indian mathematician. The first use of the idea of sine in the way we use it today was in the work Aryabhatiam. Aryabhatiam is a book written by Aryabhatta. In AD 500, Aryabhatta used the word Ardharjya for the half chord. Ardharjya for the half chord, which was shortened to Jya or Jiva. Ardharjya is after then known as a Jya or Jiva. In due course, we know that Jiva, it is known as a chord. When the Aryabhatiam was translated into Arabic, the word jiva was retained as it is. The chord, the word jiva was translated into sinus, which means cow. When the Arabic version was translated into Latin, soon the word sinus, also used as a sign, became common in mathematician texts throughout Europe. An English professor of astronomy, Edmund Gunter, first used the abbreviated notation sign. The origin of terms cosine and tangents was much later. The cosine function are aroused from the need to compute the sine of the complementary angle. Aryabhatta called it cotijia. Cotijia. The name cosinus originated with Edmund Gunter in 1674. The English mathematician Sir Jonas More first used the abbreviated notation cos. So here given some history related to sine and cosine. After then, using this sine and cosine, they generated other mathematical ratio. Remark, not that the symbol sin A is used as an abbreviation for the sine of the angle A. Sin A is not the product of sine and A. Remember that sine A, it is not a product of sine and A. Sine separated from A has no meaning. Sine A separated has no meaning. Similarly, cos A is not the product of cos A and A. Similarly, interpretation follows the other trigonometric ratio. We also there cosec A, it does not meaning it is a product of cosec and A. It is a and also cos and cosec and A are separated, then there is no any meaning. Now just think that here given one figure, if you take a triangle AMP for here that according to angle A, it will be adjacent side and it will be opposite side. So now just then if we take any ratio related to this triangle, if we take sine A, then will be PM upon AP, PM upon AP. Once again, just we take a side BC and just we extend these sides. So it will be adjacent side, AB will be adjacent side and BC will be opposite side to angle A. So we can say that if we take sine A, that it will be AB upon BC upon AC. So here you can see that we take sine A for PM upon AP and sine A AB upon BC upon AC, means if there is given angle, same angle, and if we just take other sides, then we can say that the ratio will be same. The ratio will be same. To answer this, first look at the these triangles. Is triangle PAM similar to triangle CAB? From chapter 6, recall the AA similarity criteria. Using the criteria, you will see that the triangle PAM and CAB are similar. Therefore, by the property of similar triangles, the corresponding sides of the triangle are proportional. So we have AM upon AB is equal to AP upon AC is equal to MP upon BC, and so on. We can find that. From our observation, it is now clear that the value of the trigonometric ratio of an angle do not vary with the length of the sides and the triangles. If the angle remains the same, if the angle remains the same, then the ratio will not change or does not change. Not for the sake of convenience, we may write sine square A, the square of sine, cos square A, square of A, and other etc. in place of sine A all square, cos A all square. We can just write cos square A respectively, but cosec A is equal to sine A inverse. Cosec A is equal to sine A inverse, which does not equal to sine inverse A. Once more time repeat that, sine A inverse, it is not equal to sine inverse A. We can write sine A square, it is equal to sine square A, but we cannot write sine A inverse equal to sine inverse A. It is called sine inverse A. Sine inverse A has a different meaning which will be discussed in higher classes. Similar convention hold for the other trigonometric ratio as well. Sometimes the Greek letter theta in place of A, theta, is also used to denote an angle. Remark, since the hypotenuse is the longest side in the right triangle, the value of sine A or cos A is always less than 1. Remark that, as you know that hypotenuse is the longest side in the right triangle, the value of sine A or cos A is always less than 1 or the in particular equal to 1. But it will not be more than 1. Now let us some example related to these ratios. Given that example 1, there is given one triangle ABC. There is given 10A is equal to 4 upon 3. 4 upon 3. It is given 10A. Find the other trigonometric ratio for the angle A. other trigonometry for angle A. We are going to find angle A. Let us first draw right triangle ABC. Now we know that tan A is equal to BC upon AB. BC upon AB. That is 4 upon 3. Therefore, we take BC is equal to 4K. We take BC is equal to 4K because we have just cancelled some common terms from 4 and 3, but we don't know the common terms, so we have to take BC is equal to 4K, then AB is equal to 3K, where K is a positive number that we have cancelled from both denominator and numerator. Now by using the Pythagoras theorem, here it is a right triangle, so we can use Pythagoras theorem, we can find easily AC. AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. So 4K square plus 3K square is equal to 25K square. So AC will be 5K. After taking positive square, AC is equal to 5K. So here AC is equal to 5K. Now easily we have the measure of sides. So we can easily find all the ratios. Now we can write all the trigonometry ratio using their definition. Sin A is equal to the opposite side of angle A upon hypotenuse. BC upon AC is equal to 4K upon 5K, which is equal to 4 upon 5. Cos A, adjacent side of A upon hypotenuse, is equal to AB upon AC, which is equal to 3K upon 5K, which is equal to 3 upon 5. Therefore cot A, it is the inverse of tan A. So reciprocal of tan A, that is 3 upon 4. Cosec A, it is a reciprocal of sin A. So 1 over sin A is equal to 5 over 4. And sec A is a reciprocal of cos A. So 1 over cos A is equal to 5 over 3. So easily we can find such trigonometric ratio by using their definitions. If angle B and angle Q are acute angle B and angle Q are acute angle, as you can see in the figure, such that sin B equal to sin Q. Sin B is equal to sin Q. We know that if the angle are same, then the ratio will be same. Then prove that angle B equal to angle Q. We want to prove that angle B, angle Q are equal. So we know that if the angles are, or we can say that, let us just find it. Let us consider two right triangles ABC and PQR where sin B is equal to sin Q. Sin B and sin Q are equal. We have sin B AC upon AB, opposite side upon hypotenuse, and sin Q, opposite side PR upon PQ. That is, now then AC upon AB is equal to PQ upon, or PR upon PQ. Therefore, AC upon PR, what we have done? Just we move PR here and AB here. AC upon PR is equal to AB upon PQ is equal to K. Say, now using Pythagoras theorem, BC will be is equal to square root of AB square minus AC square, and QR is equal to square root of PQ square minus PR square by using Pythagoras theorem. So BC over QR, it will be square root of AB square minus AC square upon square root of PQ square minus PR square. Now put the value of AB square and AC square, as you can see here. So K square PQ square minus K square PR square upon square root of PQ square minus PR square. K will be common, so PQ square minus PR square will be cancelled, so remaining K. So we can say that these three ratios are equal from equation 1 and 2. AC upon PR is equal to AB upon PQ is equal to BC upon QR. By using theorem 6.4, triangle ABC is similar to corresponding to triangle PRQ. and therefore angle B is equal to angle Q. We can say it easily. Now example 3. Given one triangle as you can see here. Consider triangle ACB, right angle at C, in which AB is equal to 29 units, BC is equal to 21 units, and angle ABC is theta. We just assume it as a theta. Determine the values of cos square theta plus sin square theta and cos square theta minus sin square theta. Solution. In triangle ACB, we have to just find the third side by using Pythagoras theorem. That is, we know that AB square is equal to BC square plus AC square. So we want to find AC square. So uh, AC square is equal to AB square minus BC square, and AC is equal to will be square root of AB square minus BC square. After taking square root on both sides, we can find AC is equal to square root of AC square minus BC square. Put the value 29 square minus 21 square. So square root of, we know that it is A square B square, that is 29 minus 21 into 29 plus 21. So 8 into 50, that is square root of 400, and it is a uh, square of 20. So 20 units. It will be 20 units. So sin theta, we have to find sin square theta. So we have to first find sin theta, and cos square theta. So we have to first find cos theta. Cos theta is equal to opposite side of a hypotenuse 20 upon 29, adjacent side upon hypotenuse 21 upon 29. So now first cos square theta plus sin square theta, that is the square of sin square and square of cos square. 20 upon 29 square plus 21 upon 29 square. So it will be 20 square plus 21 square upon 29 square, which is equal to 400 plus 444 upon 841, which is equal to 1. Now cos square theta minus sin square theta. So if you can say that the cos square theta plus sin square theta is equal to 1. If we take the sum of cos square theta plus sin square theta, then it will be equal to 1. It is identity that we remember that cos square theta plus sin square theta equal to 1. Cos square theta minus sin square theta, that is cos square 21 upon 29 square minus cos sin square, that is 20 upon 29 square, which is equal to 41 upon 841. So we can easily find such ratios using trigonometric ratio. So just find such example as we have discussed here. In exercise number 8.1, there is given question number 1 and 2. It is similar to these questions. Try to solve it.